Touchscreen devices, such as smartphones and tablets, represent a modern solution for providing graphical access to those who are blind or have visual impairments. However, a significant problem with these solutions is their small screen sizes, making it difficult to display the entire map. This makes panning or zooming necessary in order to view large format maps or other graphical materials, which can be difficult due to various perceptual and cognitive limitations. Two studies by Palani and Dr. Nicholas Giudice looked at this by having people learn an environment using 4 different non-visual methods of panning and 1 non-panning method. They then compared the usability between panning and non-panning in regards to learning a graphical environment in order to develop a more accurate representation of digital graphical materials. The studies consisted of a total of 15 sighted participants, ages 19 to 29, and 6 blind participants, ages 18 to 43. Both sets of participants were asked to learn 5 different graphical environments using the 4 different panning methods and the non-panning method. Participants explored the 5 maps with the different panning and non-panning methods until they felt confident they knew the layout. During the study, each of the maps had the same level of complexity, but different topologies. In addition, each map contained 1 landmark on each of the corridor segments, and the landmarks, dead ends, and junctions were all indicated to the user by audio cue. The 5 methods consisted of a 2-finger drag, a button drag, a grid tap, a button touch method, and a non-panning control. The 2-finger drag method utilizes 2 fingers in order to pan to different areas of a map. The participant would be able to explore the map with 1 finger, but would pan around once a second finger was placed on the screen. The user was notified by a clicking sound whenever 2 fingers were detected. The button touch method utilized a button in order to switch into a panning mode. The participant could explore the map with a single finger, but had to press a button in order to pan. The button drag method differed by allowing the user to use 2 fingers. The participant could explore using 1 finger, then press the volume up button in order to switch into panning mode, and the volume down button in order to return to the stationary mode. The grid tap method utilized a grid method where the app was broken up into grid-like sections. A double tap to the edge of the screen would pan the map to a different section. Finally, the non-panning method displayed the entire map on a single screen. For both groups, 8 measures were evaluated as functions of the 5 methods. Map traversals show that the blindfolded group had significantly less traversals while using the 2-finger method than any other method for the blindfolded group. Directional accuracy shows that participants were more accurate while using the 2-finger, non-panning, and button touch methods, while the button drag and the grid tap methods showed significantly more errors than the other methods. Reconstruction accuracy. The test showed that the 2-finger method was similar to the non-panning method in terms of accuracy, but were significantly better than the other 3 methods. Relative position accuracy showed no significant differences between the 5 methods. Lastly, learning time. Here, the blindfolded group's results show that there were significant differences in learning time between the non-panning method and the 2-finger drag method, meaning these 2 methods were the easiest methods for the participants to use in order to learn the map efficiently, whereas the button drag method showed the longest learning times, indicating that it was the least effective method for users to effectively learn the map. The results for the blindfolded group differed from that of the blind and visually impaired groups in that there were no significant differences for the majority of the 8 measures of the 5 conditions. Overall, the largest differences were that the blind and visually impaired groups were faster with their overall learning time with less map traversal. However, this can be attributed to their more general experience with haptic learning. These results show that overall the exploration, learning, and performance on spatial behaviors were similar between panning and non-panning methods. This means that the addition of panning operations and non-visual interfaces does not impose any detrimental effects, but instead supports the learning and building of an accurate cognitive map. The findings of these studies are a useful first step towards providing guidance for developing refreshable, non-visual interfaces for conveying large format graphics on a limited information displays such as smartphones and tablets.